Hi everyone, I'm Su-Woo Han. Today, I want to make AI-assisted development less abstract. Instead of talking about it as a trend, I will walk through BeatPaws, a web rhythm game I built for VibeJam. BeatPaws is a browser game with cat characters, 3D rhythm lanes, AI-generated music, and a full play loop. The code was written with Codex, and the music came from Gemini and Lyria. But this is not a victory lap about having AI write code. The more interesting question is this. Once Codex can generate a lot of code very quickly, what should the humans still own? My answer is goals, constraints, feel, verification, taste, and the final story. A little context on why I care about that question. I work as a computer vision engineer at BGarage, where I connect AI models to real environments, like warehouses, robots, and drones. I also serve as an OpenAI Codex ambassador, helping developers think about Codex as part of an actual workflow, not just as a shortcut. Another important part of my background is Diva Lab. I led a nonprofit collaboration that used AI to detect and track tour boats and regulation violations in drone footage, supporting conservation of dolphin habitat near Jeju. That project shaped how I look at tools. A beautiful model or a fast prototype is not enough. The work has to reach people, fit a real situation, and be trustworthy. Here is what I hope you take away. Not AI made a game. That is already becoming normal. The more useful takeaway is how to work with Codex until something is actually finished. We will look at 4 practices. First, how to start Codex with a goal, constraints, and evidence instead of a vague request. Second, how to build the smallest playable loop before you get distracted by a feature list. Third, how to tune AI-generated assets, especially music and difficulty, by listening, playing, and editing. Fourth, how to leave proof. Tests, browser checks, screenshots, progress notes, and direct play experience. If you leave with one sentence, make it this: speed is no longer the rare part. Judgment is. Games are a useful place to study vibe coding because they give feedback brutally fast. If a key press feels late, you notice. If the difficulty is unfair, you notice. If the screen looks impressive but the play is confusing, you notice. Many apps can pass the first test of the feature works. Games have a harsher test. I want to keep playing. That is why Codex is powerful here, but also why you cannot simply accept the first generated result. The loop became define the intent, let Codex build quickly, play it, notice what feels wrong, verify the rules, and edit the experience. That cycle is the operating system of vibe coding. BeatPaws started inside VibeJam, so the first prompt was not just make a cute rhythm game. The rules mattered. The local shell files acted almost like a requirements document. The game had to be newly created, free to play on the web, available without login or installation, and mostly AI written. In the submission context, BeatPaws was described as 100% AI written code, with Codex doing the coding work. A tracking widget was required, portals were optional, and I decided not to include them because the deadline risk was not worth it. These constraints made the starting prompt more product-like. No loading screen, 3JS, ASDF and HJKL controls, Gemini and Lyria music, tests, screenshots, and browser verification. So what exactly is BeatPaws? It is a web rhythm game where cat characters run across 3D lanes. The stack is Vite, TypeScript, and 3JS, and the game runs directly in the browser. Player 1 uses ASDF, Player 2 uses HJKL, and mobile players use touchpads. The chart has tap notes and hold notes. The content includes 10 Gemini and Lyria generated MP3 tracks. Each track has 4 difficulty charts: easy, normal, hard, and expert. The loop is deliberately small. Enter a nickname, choose a song and difficulty, listen to an 8-second preview, play, see the result, check a local ranking, and restart quickly. Codex wrote the code, but the human had to keep deciding what done meant. The build moved fast, but not in one clean jump. On April 30, in the morning, the project got its scaffold: Vite, TypeScript, Three.js, the VibeJam widget, and a basic game loop. That afternoon, the game started to become a game. 10 songs, difficulties, characters, scoring, and a leaderboard. At night, the work became more about feel. The note path needed adjustment, hold judgment needed to be clearer, the mobile HUD was too busy, restart flow had to be smoother. On May 1, the music side became more serious. Instead of relying only on BPM and seed-based patterns, the project analyzed the actual MP3 files and used accents to build more musical beat maps. Codex accelerated implementation, but fun appeared through repetition. The structure was not overly fancy, but the responsibilities were split. Input, rhythm, scoring, rendering, profile state, and leaderboards had separate places to live. That mattered because it made Codex easier to direct. Fix the game is a vague request. Adjust scoring windows in the core logic is much better. Change the render layer so the HUD does not overlap on mobile is better still. The core game rules were kept testable. Three.js handled the visual expression. Pure functions got tests where possible. When AI can change a lot of code quickly, module boundaries are how you keep track of what changed. The workflow was not one perfect prompt. It started with a broad goal, then narrowed through play. The important move was to keep turning messy observations into small tasks. All difficulties feel too fast. The first note feels random. Mobile fingers cover the action. The leaderboard shows duplicate records. Each of those is a better Codex task than make the game better. This is the human role in AI-assisted development. Codex can produce the code, but the human still has to notice what is wrong, name it clearly, and decide what trade-off matters. That is why /goal is useful. I think of /goal as a contract for a Codex session. A good goal is not a poetic prompt. It is a working agreement. It usually needs 4 things. First, the objective. What has to be finished? Name the artifact, not just the feature. Second, the constraints. What must remain true? For BeatPaws, that meant no loading, web first, Codex written code, Gemini and Lyria music, VibeJam rules, and specific controls. Third, the evidence. How will we know it is done? Tests, build, browser checks, screenshots, and a playable run are stronger than confidence. Fourth, a budget if you need one. The point is not to control every line of code. The point is to keep the work from drifting. The tool split was simple. Codex wrote the code, Gemini and Lyria created the music. But the boundary after generation is where the real product work begins. An MP3 file is not yet a rhythm game feature. It has to be listed in a manifest, previewed, played reliably in the browser, handled with fallbacks, and analyzed so the notes can actually connect to the music. That is a broader lesson for AI tools. The interesting question is not only which model produced the asset, the question is how that asset becomes stable inside the product. In a rhythm game, music is not background decoration. Music is data. At first, the notes were based on BPM and seeded patterns. Technically, that worked. Notes appeared, lanes existed, scoring worked. But playtesting revealed a different problem. Some first notes felt arbitrary, and some lane patterns did not feel like they were following the music. So the project moved to actual audio analysis. The generated MP3s were decoded to PCM with FFmpeg. Energy flux peaks were used to find onset and accent candidates. Those accents were classified as beat, backbeat, onset, or texture. The resulting analysis was fixed into generatedSongAnalysis.ts. Then songcatalog.ts used that data to decide which accents each difficulty should use, how dense the chart should be, and where holds should appear. Generated music can become useful game data, but a human still has to ask, does this feel right? Difficulty is not a label. Writing easy on the screen does not make something easy. Writing expert does not make it good. In BeatPaws, difficulty was a combination of target note count, minimum gaps, misallowance, playback rate, and scoring multiplier. The first real issue was that all 4 difficulties felt too fast. That meant the problem was not only expert, the whole ramp needed to be redesigned. Easy became sparse and anchored to analyzed accents. Normal became the core play feel. Hard and expert added subdivisions, short holds, tighter spacing, and faster playback. Tests can protect minimum gaps and note counts, but tests cannot tell you whether a chart feels fair. That still comes from playing it. BeatPaws did not need a huge progression system to create replay. The loop was enough. Setup, preview, play, result, rank, restart. That small loop matters because it removes friction. A player can pick a song, hear it, play, get feedback, and immediately try again. For small projects, this is a useful rule. Do not start with login, shops, quests, or a complicated economy. Start with one reason to try again. In a rhythm game, that reason can be simple: a better score, a cleaner combo, a higher rank, or the feeling that you almost had it. Mobile testing did not just reveal a smaller screen, it revealed broken assumptions. The first assumption was keyboard-first input. On mobile, that became large bottom touchpads. The second assumption was that duo mode could always be visible. On mobile, too many options created clutter, so duo was locked. The third assumption was that visual effects would always help. In narrow play, some trails were removed because readability mattered more than decoration. The fourth assumption was that controls could remain visible during the result screen. They could not. The pads had to hide when the result overlay owned the screen. Layout bugs are not abstract. They change how the game feels in someone's hands. A leaderboard looks like a simple table, but it is a product decision. If the same person plays the same song and difficulty multiple times, what should the game show? BeatPaws treated name, country, song, and difficulty as the identity key, then coalesced repeated runs into the best score. That sounds like a small detail, but it protects the experience. A leaderboard full of duplicate entries from one player is less fun and less fair. So the lesson is, storing data is not the same as designing data. The data model can either protect the game loop or quietly damage it. As Codex moves faster, evidence becomes more important. The tests covered rules and invariants, beat map shape, visible notes, chart validity across songs and difficulties, whether easy used analyzed accents, difficulty-specific note counts and gaps, scoring, input, run clock, and ranking. But some things could not be outsourced to tests. Do the notes feel musical? Is easy actually approachable? Is expert hard but fair? Does the first note feel intentional? Can you read the HUD and 3D lanes on mobile? The verification loop became unit test, build, browser smoke test, direct play, then difficulty editing. Do not trust AI output. Observe it until you can explain it. The most useful bugs were not just failures. They were design feedback. The cat character was cute, but if it covered the judgment line, cuteness was hurting playability. Some generated tracks looped, which meant the game did not end. That revealed that audio state and game state had to be connected. When all difficulties felt too fast, the answer was not just change a number. The experience had to be retuned by feel. When the leaderboard duplicated records, it showed that the data model was affecting motivation. A good bug report is not just something is broken. It tells you what the product believes and where that belief is wrong. The first lesson is to finish the smallest fun loop before adding scope. For BeatPaws, that loop was input, response, reward, and replay. Input, press a key or touch a pad. Response, see the note and judgment. Reward, score and combo go up. Replay, restart quickly and compare the result. Once that loop works, every future feature has a standard. Does it make the loop better, clearer, faster, or more rewarding? On day one, do not start with lore. Start with the loop. The second lesson is to make AI output observable. When Codex writes quickly, you need ways to read what changed. A readable state hook helped turn game state into text. Pure logic tests checked scoring, beat maps, and profile behavior without needing the UI. Browser smoke tests caught screen and console issues on desktop and mobile. Progress notes captured decisions and verification. This matters for portfolios too. If all you can say is, "I built it with AI," the story is thin. If you can show what broke, what you changed, how you tested it, and what you learned, the project becomes much stronger. Proof beats promises. The third lesson is the most human one. Codex wrote the code, but I still had to choose the direction of the game. Codex can draft, refactor, add tests, connect music, and help build verification routines. But the human still owns the questions that matter most. Is it fun? Is it readable? Is the deadline risk low? Can I explain this to another person? Would someone want to try again? AI does not make engineering judgment less important. It makes judgment more visible. Typing speed matters less. The quality of decisions matters more. Here is the playbook I would suggest for your own projects. First, ship a playable loop. Input, response, reward, and replay should fit in one small experience. Second, create product proof. Use screenshots, a short demo, or a clear user flow to show that the thing is real. Third, build an evidence system. Tests, browser checks, state logs, and progress notes make AI-generated work inspectable. Fourth, write the public story. What did you build? Where did it break? What did you decide? What did you learn? This works whether your project takes 1 day or 1 month. Build small, leave proof, edit again. From a career perspective, I think portfolios are changing. It still matters what you know, but it is becoming easier to show what you can actually finish. That is good news for builders. A strong portfolio can include a small service, a game, a paper reproduction, a workflow automation, or a tool that solves a narrow problem. But the artifact alone is not enough. You also need the narrative, why you made it, and what you learned. You need taste, the ability to notice friction and decide what to keep or remove. You need community, sharing what you learn and connecting with people. And you need impact, remembering the people and problems your technology touches. AI makes it faster to create artifacts. That makes your judgment, story, and taste even more important. Here is the message I want to leave you with. AI has made it much easier to move from 0 to 0.99. You can describe an idea, get a screen, get code, and reach something that mostly works faster than ever. But if you stop there, it becomes AI slop. BeatPaws would be no different. If it stopped at, "I made a cat rhythm game," it would just be another quick AI-made toy. The value starts changing after delivery. You show it to users. You watch where they struggle. You get feedback. you improve it. That is how 1 becomes 10. Your taste shows up in that process. What you remove, what you polish, what feeling you protect, and what values you refuse to lose. So yes, learn to use AI tools well, but also keep building your own experience, judgment, and taste. Those are the things that will still make the work yours. Let's move into Q&A. You can ask about game production, Codex workflow, verification, portfolio work, or career direction. If you already have a project idea, we can make the answer more concrete by applying today's frame to it. What is the smallest playable loop? What should Codex handle? What does a human need to judge? What proof should you leave behind? Those are usually the best questions to start with.